Hello, sixth graders. This is Mr. Warrington, and this is your Edpuzzle. Sorry. Hello, sixth graders. This is Mr. Warrington, and this is your Edpuzzle lesson on earthquakes and faults. There isn't a lot of writing to do in this one, and I'll probably actually give you a copy of the slides for you to look at later, so you really don't need to write down anything for this one. But do remember, there's questions that are coming up. Also, if you need to replay a little section to help you understand it better, feel free to do that. Pause it if you need to for a few minutes. And so let's go ahead and get started with this. Now, before we talk about what an earthquake actually is, let's talk about some different things that can cause an earthquake. And some of those things are, number one, movement of tectonic plates. As the plates, the broken pieces of the Earth's lithosphere move around and rub up against each other, those can cause earthquakes. And we'll actually look at a map here in a couple of days in class where we can actually see some of the locations of the different earthquakes in the world, and you'll see that a lot of them lie along the edges, the boundaries of these different tectonic plates. Another one are faults, and a fault is simply a break in the rock in the earth, and sometimes for different reasons that those rocks will shift relative to each other, and when they shift like that, that releases energy, and that energy flows out in the form of seismic waves, which is what we feel as an earthquake. There's a lot of earthquake action around volcanoes as well. The movement of magma underground as it starts forcing its way up, rock slides, those types of things can result in earthquakes as well. And then last, the activities of mankind. And hopefully on the interactive USGS map, we will hopefully maybe see some earthquakes caused by man occasionally. As you probably know, a lot of the earthquakes that we used to have here in Kansas and in Oklahoma were pretty much, they decided, caused by drilling for oil and a special type of drilling called fracking. They reduced the amount of fracking that they were allowed to do, and as a result of that, the number of earthquakes and the severity of the earthquakes in this part of the world has gone down quite a bit. But also, sometimes they'll use dynamite in a quarry to blast the rock out, and that can even show up as an earthquake. And a few years ago, we actually got to see on the earthquake map where they had tested, the North Koreans had tested a nuclear device, nuclear bomb underground, and it showed up as a pretty good sized earthquake. So those are some of the different causes. Now let's take a look at what an earthquake looks like, the anatomy of an earthquake. And let's start here. First of all, in this one we have a fault and a fault plane. The fault plane is the kind of the face of the fault above ground, or I'm sorry, below ground, and that's that area along which the rock can slide, and as it slides, it causes an earthquake. At the Earth's surface, that fault plane is known as a fault scarp. And sometimes, even here in Kansas, you can see fault scarps. I remember when I was young, my dad and I were deer hunting in an area, and he showed me a fault trace, this right here, which is the line of the fault on the ground, and then the fault scarp that we could see as a result of this side falling down. Now, the focus is the point down in the earth where the rock actually breaks, and it's at that point that the energy is released from. If we were to go straight above the focus to the ground, we would have the epicenter. So the epicenter is basically the location on the surface of the earth that is directly above the focus. And energy travels in waves, all kinds of energy, light energy, sound energy, all kinds of different energy travels in waves. So when this energy gets released at the focus, it will travel out in all directions as seismic waves. Now in this picture here, it kind of looks two-dimensional, like it's just going this way and this way, but it's going, as you look here, it's going outward and it's actually coming towards us as well. It's kind of like if you want to think of it as a ball that just keeps getting bigger and bigger and bigger and bigger, but it does it in waves and spurts as it spreads out from there. So that is what we would call the anatomy of an earthquake. Okay, we said one of the causes of earthquakes are different types of faults. And so we're going to look at 4 different faults here today, 2 of which are very similar to each other, and then 2 others which are a little bit different. So let's start here. And first of all, we have what is called a normal fault. And a normal fault, you have 2 different blocks. You have what's called the footwall block and the hanging wall block. And in a normal fault, what happens is because of tension, because this is being pulled this way and that is being pulled that way, when the rock breaks along that crack, this slide, the hanging wall block, will slide down relative to the footwall block. It's not that the footwall block is necessarily moving upward, it's that this one is moving down relative to this one, which makes it kind of appear that this one's moving up, even though it really isn't. And that's what we call a normal fault. Now, the footwall block, the way to remember it is it kind of looks like maybe a cartoonish foot here. You can kind of imagine that. And we'll talk about that in class a little bit. The hanging wall block, if you look at it, it is hanging on top of the footwall block. See how this section here is hanging on this section right here? So this is the hanging wall block, and this is the footwall block. All right, let's move on to the next type of fault. And actually, let me remember here, I think I have a picture. That's right, I have a picture of a normal fault here I forgot about. So this is a normal fault right here. And this person standing here kind of gives you an indication of how large this is. And so this block right here is moved downward compared to this one. And if you look, you see this line right here, how it's dark here and light up above? Now, if you look over on this side, you'll see it's dark here and light up above here. So all of this right here was once up here, way up here, and then it fell down. And when it did that, that probably caused a pretty good earthquake because it looks like it fell about 7, 8, maybe even 10 feet when it did that. Okay, the next type of fault is reverse fault. And as you'd expect, it is just the opposite of a normal fault. Now this one is caused by compression. As this block here gets pushed into this block right here, a crack will develop, and then this block gets pushed up over the top of the other one. Okay? Now this is our footwall block, and again it kind of looks like a cartoon foot. And this is the hanging wall block, and if you look at it, it is hanging on the footwall block. But in the other case, in the normal fault, this one fell down. In this case, this one's being pushed into the other one, and so it actually pushes up and over the top of the other one. And that is why it's called a reverse fault. So in a reverse fault, the hanging wall block is above the footwall block. It has been pushed up over the top of the footwall block. Here's a picture of a reverse fault, and you can see this person standing here. This is a small one, and you can see this is the fault plane right here, this dotted line, and then this right here used to be clear down here. You can see how this got pushed up this direction relative to this one. This one probably actually didn't move any. If it did, it didn't move much. It's more this one getting pushed up over the top of the other one. Okay, now the last type are what we call strike-slip faults, and there's actually two different types of strike-slip faults depending on what direction it has moved. So, in a strike-slip fault, the two sides move relative to each other. This one, in this case, is moving this direction. This one is moving this direction relative to each other. Probably only one of them is moving. Like this one might be being pushed this way, or this one might be being pushed this way. But in either case, they move side to side with respect to each other rather than up and down. Now, the hardest part with strike-slip faults is figuring out if it's a right lateral strike-slip fault or if it's a left lateral strike-slip fault. And the best way I know to do this is to pretend maybe that you are standing over here on this side and you are looking over across to this side. And what you want to do is look at what direction the other side moved compared to you. In this one, you can see that it moved to your right. So that makes it a right lateral strike-slip fault. And so you can imagine that a left lateral strike-slip fault is just the opposite. So let's take a look at it. And again, what you have to do with these is kind of imagine yourself, kind of put yourself in the picture. So if you were standing on this side, some of you are really going to enjoy my artwork here, and you're looking this direction over to this side, you see that it's moving towards your left. Now, the crazy thing about this is that if you were standing on this side, and I forgot to show you this on the other one, if you're standing on this side and you're looking this direction, what direction would it look like it was moving? Well, it would also look like it is moving towards your left. So no matter which side of a strike-slip fault you are, you can tell what kind it is depending on what direction the other side has moved compared to you. You may have been moving, or the side you are standing on may have moved, the one across from you may have moved, and so you're looking at how they have moved relative to each other. And in this case, no matter which side you stand on, it has appeared to move to the left, so this would be a left lateral strike-slip fault. Okay, now we're going to test you on this on the next picture. So this is a strike-slip fault that has occurred somewhere on Earth. I'm not really sure. You can actually see the fault trace here a little bit on both sides of the road. And it's a strike-slip fault. And what I want you to do is to tell me what kind you think it is, a right lateral or a left lateral strike-slip fault. All right, well, this was actually a pretty short lesson, and we'll talk about some of these things in class, let me see here, in a couple of days. And as good, it's always to kind of study these things ahead of time, so when we talk about them in class, you have a pretty clear understanding of what's going on. All right, that's all for this lesson. All secure in Sector 7, and we'll see you later. Bye-bye.